Force, energy and machine. Learning objectives. What is force? Effects of force. Types of forces. Energy. Law of conservation of energy. Simple machines. Types of lever. Every time you move something, use a pencil or walk, you are applying force. These forces are examples of everyday life. Force can be defined as a push or a pull. For example, when you throw a baseball, you apply a force to the ball. Force is measured in Newton, N. What is force? A force is a push or pull upon an object resulting from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. Force and motion are closely connected. In general, most things are standing still. But as you look around, you may see things that suddenly start to move for one reason or another. For example, an apple falling from the tree. An apple falls from the tree to the ground. Some men push a stalled car down the street. You blow up a balloon, and it flies away as the air rushes out. You hold a stick underwater and after you let it go, it shoots up to the surface. Effects of force. Force can be measured in terms of either of two effects. A force can either change the size, shape of an object or change the speed of an object and make a stationary object move. Let's see its effects through examples. 1. Force can make a big object move or make a moving object faster. In the picture below, a girl is moving a stroller by applying a small push. A moving football can be made to move faster by applying an additional push. 2. Force can change the speed of a moving object. The moving toy cycle can be made to stop by applying a force. In the picture, a boy is cycling fast and he stops it by applying the brakes. 3. Force can change the direction of a moving object. In the picture, player hits a cricket ball with a bat. Due to this, direction of ball changes. 4. Force can change the size and shape of an object. In the picture, a girl is squeezing the toothpaste tube. Tube changes its shape. Potter can make many pots in different shapes by applying a force. A girl moving stroller. A boy cycling. A player hitting a ball. A girl squeezing toothpaste. Types of forces. There are different types of forces. Gravitational force. The force of gravity is the force of attraction between all objects that tends to pull them towards one another. It is a force affecting the largest and smallest objects. This force controls the movement of heavenly bodies. It keeps the moon in orbit around the earth and keeps the planets in orbit around the sun. Gravitational force. English physicist and mathematician Sir Isaac Newton is considered to be the father of modern science. Newton was the first to propose the laws of gravity after being hit on the head by a falling apple. Sir Isaac Newton. Electrostatic force. To understand this force, let's do an activity. Tear a paper in small bits. Comb your hair with plastic comb and bring it close to small bits of paper. You will see that small bits of paper get stuck with the comb. This happens because when you rub any object, it gets charged and attracts the small particles. This force is called electrostatic force. This happens due to electrostatic force. Electrostatic force. Magnetic force. Magnetic force is a force that attracts an object. Magnetic forces are produced by the motion of charged particles. The most familiar form of magnetism is the attractive or repulsive force that acts between magnetic materials such as iron. Magnetic force. Frictional force. It is the force that has an effect on the speed of an object. It cannot change the direction. It acts to slow down or stop a moving object. It takes more force to stop an object from moving. It stops or slows down object when it is in motion. Friction can be used for many important things such as helping the wheels of a train or car to stay on the rail track or road simultaneously. You need friction to walk. If you did not have any friction, everything would be slipping and sliding away. That is why you cannot walk on ice very well. Ice is so smooth and flat that it produces less friction than a sidewalk, making it hard to walk on ice. Friction between tire and road. Walking is not easy on ice with less friction. Rolling resistance. Friction occurs anytime when two objects or surfaces are rubbed together. Important uses of friction. In some situations, friction is very important and beneficial. There are many things that you could not do without the force of friction. Walking. You cannot walk without friction between your shoes and the ground. As you try to step forward, you push your foot backward. Friction holds your shoe to the ground, allowing you to walk. Walking. Writing. Writing with a pencil requires friction. You cannot hold a pencil in your hand without friction. It would slip out when you tried to hold it to write. The graphite pencil lead would not make a mark on the paper without friction. Writing on pad. Driving cycle. Your cycle would not start moving if it was not for the friction of the tires against the street. With no friction, the tires would just spin. Likewise, you could not stop without the friction of the brakes and the tires. A girl cycling. Energy. Energy makes change. It does things for us. It runs train on the track and boat over the water. It keeps water cool in freezer and makes the food in cooker. It shows our favorite movie on television and runs fan in the rooms. Scientists define energy as the ability to do work. Forms of energy. Energy is found in different forms, such as radiant or light, electrical, heat, sound, mechanical, wind and hydroelectric. Radiant energy. It is electromagnetic energy that travels in transverse waves. Radiant energy includes visible light, X-rays, gamma rays and radio waves. Light is one type of radiant energy. Solar energy is an example of radiant energy. Solar energy. Electrical energy. It is the movement of electrical charges. Everything is made of tiny particles called atoms. Applying a force can make some of the atoms move. Electrical charges moving through a wire is called electricity. Lightning is an example of electrical energy. Electrical energy. Heat energy. It is the internal energy in substances. Sun is the example of heat energy. Wood, coal, kerosene are also sources of heat energy. Heat energy. Sound energy. Sound is the movement of energy through substance in waves. Sound is produced when a force causes an object to vibrate. The energy is transferred through the substance in a wave. Sound energy. Mechanical energy. Energy that an object has because of its position or its movement is called mechanical energy. It is of two types, potential energy and kinetic energy. Energy which is a moving object possesses is kinetic energy, and the energy which is stored in an object by virtue of its position is potential energy. For example, a moving car possesses kinetic energy and a stretched bow possesses potential energy. The water stored behind a dam possesses potential energy, but when it falls from a height, the energy gets converted to kinetic energy. A stretched bow. Water stored behind a dam. Examples of potential energy. Wind energy. Wind energy is a renewable source of energy. It does not pollute and it is environment friendly. Wind is converted into energy by the wind turbines. When the wind turbines spin, they convert wind energy to electrical energy. Wind turbines work in a group in wind farms. Windmills in a wind farm. Hydroelectric energy. It is one of the oldest sources of energy. We have been using this energy to produce electricity. Dams are set up to collect the running water. It is allowed to flow through tunnels to convert it into electricity. Hydropower station. Law of conservation of energy. Energy changes its form. It can neither be created nor be destroyed, but it can be stored. A cell is an example of stored chemical energy. A cell makes a toy car move. It also makes a clock or a watch show us time. Simple machines. Simple machines are tools that make work easier. They have few or no moving parts. These machines use energy to work. There are different types of simple machines. 1. Lever. A lever is a simple machine. A lever is a board or bar that rests on a turning point. This turning point is called the fulcrum. An object that a lever moves is called the load. The closer the object is to the fulcrum, the easier it is to move. The force you apply with your weight is called the effort. Here is an example of a lever being used to move a rock. The rock is the load. The place that the board rests on is called the fulcrum. Using this lever makes the work of moving the rock a lot easier. A man lifting a rock with lever. A lever machine. Load. Effort. Fulcrum. Types of lever. Levers are all around us. Hammers, axes, tongs, knives, screwdrivers, wrenches, scissors, all these things contain levers. All of them give leverage, but not all of them work the same way. There are actually 3 different kinds of levers, sometimes known as classes. Class 1 levers. In a Class 1 lever, the force you apply is on the opposite side of the fulcrum to the force you produce. A seesaw is an example of a Class 1 lever. So is a pair of scissors. Load. Effort. Load. Fulcrum. Shearing point. Top blade. Bottom blade. Pivot. Applied force. Output force. Input force. Fulcrum in the middle. Class 2 levers. A Class 2 lever is arranged in a slightly different way, with the fulcrum at one end. You apply force at the other end and the force you produce is in the middle. Nutcrackers, bottle opener, and wheelbarrows are all examples of Class 2 levers. Wheelbarrow. Effort. Load. Fulcrum. Bottle opener. Load. Effort. Fulcrum. Load. Effort. Fulcrum.
Class 3 levers. A Class 3 lever is different again. Like a Class 2 lever, it has the fulcrum at one end. But the two forces switch around. Now you apply the force in the middle and the force you produce is at the opposite end. Class 3 levers are unlike other machines in that they reduce the force you apply, giving you much greater control. Tweezers and tongs are an example of Class 3 levers. Fulcrum. Effort. Load. Load. Effort. Fulcrum. Fulcrum. Effort. Load. Activity 13.1. You need wooden ruler, textbook and a desktop. Method 1. Lay a ruler on your desk with part of it hanging over the edge. Place a textbook on the other end. 2. Try to lift the textbook by pressing down on the part of the ruler that is sticking out. Repeat this procedure several times. 3. Move the textbook closer to the edge by pulling on the ruler. Continue until the book is right at the table's edge. 4. The edge of the table is the fulcrum and the textbook is the load. It is easier to move an object like the textbook when the fulcrum is closer to the load. 2. Inclined plane. An inclined plane is a simple machine. It is a flat surface that is higher on one end. You can use this machine to push up or roll up objects on a lower or higher place. Inclined planes make the work of moving things easier. An inclined plane. A ramp is an example of an inclined plane. Examples of inclined planes. 1. Ramp. 2. Slanted road. 3. Path up a hill. 4. Slide. 3. Wheel and axle. The wheel and axle is another simple machine. The axle is a rod that goes through the wheel. This lets the wheel turn. It is easy to move things from place to place with wheels and axles. Examples of wheel and axles: 1. Cars. 2. Roller skates. 3. Wagons. 4. Doorknobs. 5. Gears in clocks and bicycle. A wheel and an axle. 4. Screw. A screw is a simple machine. It is actually an inclined plane that winds around itself. A screw has ridges and is not smooth like a hail. Some screws are used to lower and raise things. They are also used to hold objects together. Example of a screw: 1. Jar lids. 2. Light bulbs. 3. Stools. 4. Clamps. 5. Jacks. 6. Wrenches. Screws. Activity 13.2. Materials: 9-inch paper square, pencil, tape, marker, tabletop. Method 1. Cut the square in half to make a right triangle. Use the marker to outline the diagonal side of the triangle. Now place the paper face down on the table. Place the pencil on one of the short sides of the triangle. Wrap the pencil around the triangle. Use the tape to keep it in place. 2. Things to think about during the experiment. 3. What simple machine is the right triangle? 4. What simple machine was created when you wrapped the pencil around the triangle? 5. Name some examples of this machine. Conclusion: you made a screw out of an inclined plane when you wrapped the triangle around the pencil. 5. Wedge. A wedge is a simple machine used to push two objects apart. A wedge is made up of two inclined planes. These planes meet and form a sharp edge. This edge can split things apart. You probably use a wedge at lunch every day. A fork is considered a wedge. A fork can be used to cut or split food apart. Examples of wedges: 1. Knives. 2. Axes. 3. Forks. 4. Nails. Knife, axe, fork, nail. 6. Pulley. This simple machine is made up of a wheel and a rope fits on the groove of the wheel. One part of the rope is attached to the load. When you pull on one side of the pulley, the wheel turns and the load will move pulleys. It lets you move loads up, down and sideways. Pulleys are good for moving objects to hard-reached places. It also makes the work of moving heavy loads a lot easier. Examples of pulleys: 1. Flagpoles. 2. Clotheslines. 3. Sailboat. 4. Blinds. 5. Crane. A compound pulley. Summary: a force is just a push or a pull upon an object. A force either can change the size or shape of an object, change the speed of an object and make a stationary object move. The force of gravity is the force of attraction between all objects. Magnetic forces are produced by the motion of charged particles. Electrostatic force is produced when we rub any object. Friction occurs any time when two objects or surfaces are rubbed together. Energy is the ability to do work. Energy is found in different forms, such as light, heat, sound and motion. Simple machines are tools which make work easier. Energy can be converted into different forms. There are 3 types of lever. Fixed point while operating a lever is called fulcrum. Keywords: force, a push or pull acting on an object. Friction, a force occurring any time when two objects or surfaces are rubbed together. Gravity, a force which pulls things towards itself. Simple machine, a device for overcoming resistance at one point by applying force at some other point.